Welcome student. Today our topic is first come first served algorithm. From today onwards we will do different CPU scheduling algorithm. So our first class will be started with first come first served algorithm. These are the course outline of our class. First we will learn the basic introduction of first come first served algorithm. Then we will do some assignments on first come first served algorithm, that is the mathematical part of the program. And next one is the advantages of first come first served. Next one is disadvantages of first come first served, and the last one is the convoy effect. So these are the learning objectives and learning outcome. So in learning objective is mainly to provide you the services and the design technique of operating system, to understand what a process is and how processes are scheduled. And the learning outcome describe how computing resources such as CPU, memory, I/O are managed by the operating system, solve different CPU scheduling problems to achieve specific scheduling criteria, apply the knowledge of process management to solve basic problems. So just see the diagram. So in this diagram, the blue door, mainly in this door, assume this is a bank, or this is a ATM counter, or this is the railway ticket counter. So whoever will come first, he or she will be served first. So in this case, the first person standing in this queue is a lady, an old lady. So she will be served first, then a young man, he will be served, then another old man, he will be served, and then there is another young lady, she will be served, and there is also a kid, and after that there is a mature man. So by this manner, whoever is arrived first, he or she will be served by the system. So in that case, mainly just see the first point, jobs are executed on first come first served basis. It is a non-preemptive scheduling algorithm. Non-preemptive means our computer CPU will allow all the processes. Those are non-preemptive. Non-preemptive means it will never interrupt the execution, or it will never stop the execution until it completes its task. So this is the non-preemption. So next one is the easy to understand and implement. Its implementation is based on FIFO-Q. 4 in performance as average wait time is high. So these are the main point you have to remember. Now just see, this is another very popular diagram. It is available all over the internet. So here process 1, process 2, process 3, process 4, process 5, process 6, and all these processes are represented by a person. From person 1, person 2, person 3, person 4, person 5, person 6. And there is a processor or a stage is there, mainly the central processing of the system, and whoever is come first, he or she will be served. So by this manner, just this is a very funny diagram by which you can remember the technique or the procedure, how first come first serve is executed. So assume this is our first mathematical problem regarding first come first serve. So there are 4 processes, process 1, process 2, process 3, process 4, and in every time there is another column, that is the burst time. Burst time means the execution time, how much time it will take to complete its execution. So process 1 will take 21 unit of time, process 2 will take the 3 unit of time, process 3 will take 6 unit of time, process 4 will take 2 unit of time. And now you see here, there is no arrival time is given. So whenever there is no arrival time is given, that means you have to assume that all the process has arrived at the same time, and we assume that all the process has arrived at the time of 0. So now see the ready queue over here. In this ready queue, just see at the time of 0, process 1 has entered into the system, And what is the execution time of the process 1? That is the 21. So process 1 entered into the system at the time of 0 and it will release the system after 21 seconds. After 21, who will come? That is the process 2 will come. Process 2 will enter at the time of 21. So after its execution time or burst time is 3, so it will release the system at the time of 24. Next is process 3. Process 3 has arrived also in the same time, and now process 3 execution time is 6. So 24 plus 6, it will exit from the system at the time of 30. Similarly, process 4 is execution time is 2. So process 4 will enter into the system at the time of 30. After 2 seconds or 2 unit of time, it will release from the system. So by this manner, we have to calculate the waiting time for P1. So what is the formula of waiting time? Waiting time formula is waiting time for process 1 is the starting time of process 1 minus arrival time of process 1. So in this case, process 1 starting time, process 1 has been started when? At the time of 0. So 0 minus 0 equal to 0. So waiting time for process 2. Waiting time for process 2, execution time or service time or starting time for process 2 is 21. So 21 minus 0 equal to 21. Waiting time for process 3. So process 3 will be started at the time of when? 24. So 24 minus 0 equal to 24. Waiting time for process 4. Process 4 waiting time is 30. 30 minus 0 equal to 0. So average waiting time is 0, 21, 24, 30. So if I add them and divide them, so we will get 18.75 millisecond, or the unit of time is the average of waiting time. So by this manner, you have to derive the waiting time all the individual processes. After calculating the processing time or waiting time of each processes, you have to find out the total waiting time. After calculating total waiting time, you have to divide it by the number of processes. Here, how many processes are there? There are 4 processes are there. That is why whenever we are calculating the average of waiting time, we have to divide by 4. So these are the things you have to remember. Next one, for the same problem, we will calculate the turnaround time. So how we will calculate the turnaround time? So turnaround time mainly calculated by the completion time of process 1 minus arrival time of process 1. Similarly, turnaround time for process 1. So process 1, just see the diagram. Process 1 has been started at the time of 0, but process 1 completes its execution at the time of 21. So that means process 1 completion time is 21 minus arrival time. We assume that arrival time is 0, that is why it is 21. Turnaround time for process 2. Process 2 completion time is 24. So 24 minus 0. Again process 3 completion time is 30 minus 0. That is the 30. Again process 4 completion time is 32. 32 minus 0 to 0. So first we have to find out the average. It is a typing mistake. It will be the average turnaround time. That is the 21, 24, 30 and the 32, and here average will be 26.75. So just it will be a correction over here. Average turnaround time will be 26/75. Similarly, the response time for the, I am telling you over here, first come first serve is a non-preemptive scheduling algorithm. That is why starting time of P1 or the first response for process 1. So whenever process 1 may come into the system earlier, but at the time of or at the moment of when process 1 give you the first response, process 2 will give you the first response from the system. Process 3 will give you the first response from the system. Process 4 when will give you the first response from the system. So by this manner, again process 1 first response we are getting, that is at the time of 0. Process 2 first response we are getting at the time of 21. Process 3 response time will be getting at the time of 24. Process 4 response time at the time of 30. So process 1 will be 0 minus 0 response time. Response time for process 2 will be 21 minus 0. Again response time for process 3 24 minus 0. Response time for process 4 30 minus 0. So by this manner here is also 18.75. So just one thing you have to remember, for non-preemptive scheduling algorithm, average response time or average waiting time will be same. Okay, so ART equal to AWT. This thing you have to remember here. Okay. So this is another example. Just see this is example 2, and this example is very much popular over the internet. In many website or many study material, if you go through, you will get this example. So there are 4 process also: process 0, process 1, process 2, process 3. They have given, there are one extra column is here, that is the arrival time, and this is the execution time or the burst time. Initially I will tell you, just ignore the service time column. You don't need to consider the service time column over here. So at the time of process 0, who is coming? At the time of 0, process 0 has been coming, and execution time for process 0 is 5. So process 0 will enter over here 0 and exit from the system at the time of 5. Okay, now process 1 already arrived. Okay, until process 0 will complete its execution, process 1 arrived, process 2 arrived, process 3 already arrived. Okay, but in case of first come first serve, according to the arrival sequence, execution will be done. So process 1 will enter from the system, enter into the system at the time of 5. Execution time of process 1 is 3 over here, so 5 plus 3 8. Similarly process 2 arrived already at the time of 2, but its execution time is 8, so 8 plus 8 equal to 16. Similarly process 3 arrival time is 3, but it is again plus 6, so 16 plus 6 it will be 22. Similarly we will find out the waiting time for P0, waiting time for P1, waiting time for P2, waiting time for P3, and waiting time for total waiting time of the system, and as well as the total waiting time of the system will be 23. And there are how many processes are there? There are 4 processes are there. That is why whenever we want to calculate the average waiting time, we have to divide it by the 4, and your answer will be 5.75. Similarly for turnaround time, we have to consider the completion time minus arrival time whenever we are calculating the turnaround time. So turnaround time for process 0 will be, process 0 is completing at the time of 5, so that is why 5 minus 0. Process 1 is completing at the time of 8, that is the 8, but process 1 arrival time is given over here 1, so 8 minus 1, that is 7. Turnaround time process 2, process 2 is completing at the time of 16, this is 16, and process 2 arrival time is 2, so 16 minus 2 equal to 14. Turnaround time for process 3, that is the process 3 will complete 22. Process 3 is completing at 22, just oversee here, slide has been changed before. So this is 22 minus 3, that is 19. So total turnaround time will be, first you have to addition, you have to do the addition operation over here. Turnaround time for process 0, turnaround time for process 1, turnaround time for process 2, turnaround time for process 3. So by this manner you have to find out the total turnaround time by 4, and your answer is over here is 11.25. Okay, so similar is also average response time and average waiting time is just like previous case. Whenever you are getting the first response from the system, that thing you have to consider. Okay, so first response time minus the arrival response time is the case over here. Okay, so first thing you have to remember, in first come first serve is non-preemptive in nature. In first come first serve, waiting time equal to always response time, and waiting time less than less than turnaround time. Turnaround time is much more higher than the waiting time. This is the rule for first come first serve problem. You have to remember. Now this is one assignment, you have to do it yourself. So just say the question. So consider the processes listed below. Consider the following first come first serve algorithm. So there are how many processors there? There are 4 processors there, A, B, C, D. So how many processors there? A, B, C, D is a given. Arrival time is given 0, 1, 2, 3. So at the time of 0, process A arrived. At the time of 1, process B arrived. At the time of 2, process C arrived. At the time of 3, process D arrived. Similarly, the execution time 8 nanosecond for process A, 4 nanosecond for process B, 9 nanosecond for process C, and 5 nanosecond for the process D. So number 1 question, you have to draw the Gantt chart of illustrating the execution time of the all processes. So these are the first step of your problem, and next you have to find the average of waiting time for each of the scheduling algorithm and find average turnaround time for each of the scheduling algorithm. So average turnaround time and average waiting time, these two things you have to calculate over here. So now consider the part 1. So part 1 means you have to draw this diagram. This diagram is called the Gantt chart, and whenever you will be able to represent this Gantt chart, that means you will get 2 marks in your exam. So now just see here, at the time of 0, who is coming? Process A is coming. What is the execution time of process A? Is 8. So at the time of 0, process A will enter over here, but at the time of 0, process A will exit from the system. Similarly, during this execution of process A, rest of the B, C, D, they all have arrived. Okay, so at the time of 8, so after 8 seconds, A is completing its execution. So you don't need to consider the process A after that. Okay, now after A, who has come? After A, B has come. So B execution time is 4. That is why 8 plus 4, 12. So B's exit time is 12. Similarly, C is a process arrival time and burst time. So C will be started at 12 plus 9, that is C will complete it at 21. Similarly, process D will start at 21, but after 5 seconds. So 21 plus 5 equal to 26. At the time of 26, D will exit from the system. Now I am giving you some time. So find out the average waiting time, and we will find out the average turnaround time of the system. Okay, so give heading how to find out the average waiting time. How we will find it? So just see the table. So in the table, from this Gantt chart, what are the thing is common? You know the processor's name. You know in where or how the process has been started. So process A starting time is 0. Process B starting time is 8. Process C starting time will be sorry, here is some mistake is again over here. So process C starting time will be 12. Process D starting time will be 21. Okay, so arrival time is also given. So 0, 7, this will be 12 minus 2, that is this will be 10, and this number will also be changed over here. Okay, so by this manner you have to calculate the completion time, and similarly after completion time, A's completion time is 8, B's completion time is 12, C's completion time is 21, D's completion time is 26. So these are the thing. This is the turnaround time, means you have to completion time minus arrival time. So these two column will be subtracted in each case. So after subtraction you will get this value. After getting this value, this is the average turnaround time. You have to calculate And okay, so by this manner you can do your job by simply drawing a table also. If you don't want to write everything in every step, that is the average waiting time for process 1, average waiting time for process 2, or turnaround time for process 1, turnaround time for process 3, all are new into this system. Okay, so here you have to calculate all this value and find out the average waiting time and average turnaround time. So in that case you can solve your problem by this tabular manner also. This is up to you. Okay, so what is the advantage? So advantage of first come first service, it is simplest and easy to implement algorithm. The first come first serve algorithm is implemented using FIFO queue in the data structure. Just like in FIFO, the data element enters from the tail of the queue and exit from the head of the queue. So I am just going to the first diagram in our program. So here this is the first point, this is the last point. In this first point it will enter into the system, and this is the last point. Okay, this thing you have to remember. So first come first serve algorithm is implemented using FIFO queue in the data structure. Just like FIFO, the new data element enters from the tail of the queue and exit from the head of the queue. Okay, similarly in first come first serve, the CPU scheduler serves the processes present at the head of the ready queue. Okay, next one, it works well with the processes that have long burst time. This is advantage, this is disadvantage. The scheduling method is non-preemptive. The process will return to the completion. Due to the non-preemptive nature of the algorithm, the problem of starvation may occur. Although it is easy to implement, but it is poor in performance since the average waiting time is higher as compared to other scheduling algorithm. Number 4, the first come first served method exhibits convoy effect, which lower down the CPU and IO utilization. As for the execution of the one big process, the other short process have to wait. So just go to the next point. This is the convoy effect. Assume in this just go to the diagram. In this diagram, in this big truck or bus, assume this is a longer job, and after that there are many small jobs are waiting. Whenever CPU will release from the long job, then process 2, process 3, process 4 will be solved. So convoy effect means when one process with big burst time will schedule first, and then all the process have to wait to get blocked until big process get off the CPU is called convoy effect or starvation. So this point process, assume process 1 is a long process, process 2, 3, 4 they have to wait until process 1 released from the system. Okay, and this kind of blocked until the process get off the CPU is called convoy effect or starvation, and this type of phenomenon are called starvation or convoy effect. It produces huge average waiting time, which means utilization of CPU gets lower. Now see the diagram. In this diagram there are 3 processes, process 1, process 2, process 3. This is the arrival time 0, arrival time 1, arrival time 1, and the burst time of the first process is 30. This is 3, this is 1. So just as per the first come first serve rule, who has arrived over first? At the time of 0, process 1 has arrived. At the time of 0, process 1 has arrived, and at the time of 0, process 1 entered into the system at the time of 0. At the time of 30, process 1 exit from the system. Similarly, process 2 has arrived at the time of 1, and next process 2, as per their arrival, process 2, next process 3 will arrive, and this is the completion time of process 3. So by this manner, if you want to calculate the average waiting time, so average waiting time for this system is 20.33 nanosecond or millisecond, whatever the unit they will give you. Okay, so how to overcome this problem? How to overcome this kind of problem? That means there is a solution where whatever the longest processes are there, we will keep them at the end of the work or end of the system. So by this manner, we think that process execution will be, or the average waiting time will be considerable. So in this case, just see process 2 and process 3 both are process 2 and process 3 both are arrived at the same time. So process 2, process 3, and at the end, which process are long enough, this process will go to the at the end of the communication. So here just see that process, instead of process 1 will be started in the Gantt chart, process 2, then process 3, then process 1 will be in the chart. So by this manner, first you have to identify the schedule time, the completion time, the turnaround time, and the waiting time. This chart you have to prepare first. After preparing this chart, you can easily find out the average waiting time also. And this kind of problem are very, very important for your exam. So these are the books I am recommending you. First, initially I will guide you. You just go through the books of operating system basics, and as well as the books of any programming part of the first come first serve. These things are very, very important. So these are the important questions which are very, very much important for your semester exam. That is what are the advantage and disadvantage of first come first serve algorithm, what is convoy effect or starvation, how this problem can be solved, and find out the average waiting time, average turnaround time for the following processes by first come first serve manner. So this is the arrival time 0, 2, 3, 4, and at the time of 0, process 1 will get system is empty, there is no other competitor, so process 1 enter into the system, and until completes its execution it will never release the system. So at the time of 7 it will again it will exit from the system. Rest P2, P3, P4 will enter into the system and complete its execution. Okay, so in this case, just see the convoy effect. If I go to the convoy effect, average waiting time is much more higher than the usual day. So in this case, process 2, process 3 will execute first. Next, we will at the end we will add the long processes. That is the process 1. Okay. So this thing are called as this thing is by this manner. If you consider this, so just see the average waiting time is now 2. But in case of previous problem, average waiting time was 20.33. So there are huge gap between these two approaches. Okay, so these are the books. This is the Galvin books or any other operating system books like Balakrishna Prasad, or any other books like where the algorithm are explained well, and the online courseware of our college. So these are some important questions. What do you mean by convoy effect or starvation? How this problem can be solved? You have to explain with a small example. Next one is find out the average waiting time and average turnaround time for the following processes by first come first serve. Similarly, process 1, process 2, process 3, process 4. Now they will have arrival time and process time. How you will do this problem? Okay, how you will solve this problem? These things are important for your exam. So these are the link I am here mentioning. You can get me at by the help of email. You can reach by the link of LinkedIn, by the link of Facebook, by the link of YouTube. Anywhere you can contact me. If you have any confusion related to the class, you just drop a message over there, and I will try my level best to give you the best solution over there. So these are the things you have to remember. Very recently I have launched my YouTube channel. Please go there, join the course, and enjoy your semester. No problem is there. Okay, so So by this end we will conclude our session. So I'm again going to the previous point. In the previous point, by this manner a table will be given, and by the help of this table you have to find out the average waiting time, then you have to find out the average turnaround time, then you have to arrange the average response time. By this manner you have to calculate all. Okay, so these are the things you have to prepare for your exam. If you have any question, just drop me a message. These are the link. My email ID is devastri.mitro@jscollege.ac.in. My personal email ID is devastri.mitro2005@gmail.com. These are the LinkedIn profile I have. This is the Facebook profile where you can reach me. This is the YouTube link where you can reach me also. So this is the thing. And if you have any question, you just drop me a message. Okay, thank you for your student for your patience.